Now in this lesson, I'm going to be teaching you guys what we know as structural analysis. What is structural analysis? Structural analysis is the determination of the effect of load on physical structures and their components. What do we mean by this? We as civil engineers, our job is to analyze buildings and design. Okay, and we know that structures, they are always subjected to load, right? They are always subjected to load, like environmental load, which is wind load, earthquake load, and structures, they are also subjected to life load and dead load, which is their own set weight. So guys, we know these structures, they are always subjected to load. So we structural engineers, we are trying to analyze the effect of this load on the structures. Structural analysis is the determination of the effect of load on physical structures and their components. Due to the effects of this load, these structures, they are going to have what we know as stresses or stress resultants, right? Because due to this load, the structure is going to receive some stress, right? So the structures is going to be stressed. Okay, we are going to have something like axial or shear forces, and we're also going to have a bending moment or torque. Okay, because this structure, they are experiencing load. So what do you expect, guys? This structure is going to be stressed. Okay, so we're going to have axial or shear forces or bending moment and torque. Also guys, this structure is going to try to deform, okay, because the structure is experiencing load. Okay, whenever a structure is experiencing load, what do you expect, guys? The structure is going to deform. Okay, so guys, this deformation is going to result to deflection. Okay, the structure is going to try to deflect, and the structure is also going to try to rotate. So this is rotation. The support reaction, this is the forces or the moments required to meet equilibrium. Okay, we also need to have the external force that is going to counteract this environmental load. Okay, so we need to have support reaction that will counteract this environmental load in order for the structure to meet equilibrium. Now, how do we go about this? We need to make sure that the structure is always at equilibrium. The summation of the forces in the S direction or the S axis need to be equal to 0, or the summation of the forces in the Y axis need to be equal to 0, or the summation of the moments produced need to be equal to 0 in order for this structure to be at equilibrium. We also have constitutive relationship. That is the relationship between stress and strain. We also need to know the relationship between stress and strain in order for us to analyze the buildings. Okay, so this is the idea of Hooke's law. Okay, that is stress and strain, they need to be proportional. Okay, guys, so we need to understand the idea of Hooke's law, which is stress and strain need to be proportional. Okay, so we need to understand this in order for us to analyze our buildings. The stress is equal to the modulus of elasticity multiplied by the strain. So E is equal to modulus of elasticity. So this is equal to stress over strain. We also need to know that the displacement should be continuous. If you have a beam, as you can see, guys, if you take a look at this picture, if you have a beam that is resting on a wall, if you apply a force on this beam is going to displace. So the displacement of this beam is going to be continuous. This is the position of the beam, right? So if we apply a force on this beam is going to change its position. Okay, so this beam is going to try to displace downward. Okay, guys, so the displacement should be continuous. This is what we know as cantilever beam. Okay, so this is the beam. This is a type of beam that has just one support. Okay, as you can see, this beam is attached to the wall. So this is what we know as cantilever beam. Okay, guys, so let's move to the next slide. Why do we care? Why do we care about structural analysis? Like, what is the big deal of structural analysis? The reason we care about structural analysis is design. We want to be able to design our buildings, right? We want to be able to design our buildings. So, and how can we design buildings if we don't know how to analyze buildings? If you don't know how to analyze buildings, how can you design buildings? It is impossible. Okay? So the reason we care about structural analysis is because we want to be able to design our buildings. Yes, because the job of a structural designer or the job of a civil engineer is not just analyzing. The job of a civil engineer is to design. Okay, guys? Because if you know how to analyze, but you don't know how to design, then there is no point. There is no point analyzing structures when you can't design structures. Okay? So the main reason we care about structural analysis is because we want to be able to design buildings. Okay? We want to be able to determine the size of a beam that is going to withstand the environmental load. Okay? So we want to be able to determine the size of beams, determine the size of columns, determine the number of bolts we are going to use for our structures. Okay, guys, we want to be able to determine what materials do we need on our structures in order for us, or in order for the structure to withstand the environmental load. Okay, so the main job of a civil engineer is not just to analyze, is to design. Okay, so this is the reason we care about structural analysis. Now, how do we go about structural analysis? How do we go about structural analysis, guys? Now, guys, this is what you need to know. Structures are very, very complex. Now, guys, if you take a look at this structure on the right or this structure on the left, as you can see, guys, this is a very, very complex structure. Okay, and this structure, they have all sorts of responses. This structure, they can be subjected to vibrations, or this structure, they are subjected to all kind of geometric nonlinearity or material nonlinearity. That is to say, material nonlinearity as concrete or steel buildings, right? Because in a structure, we have concrete, right? We have concrete, we have steel, we have all sorts of materials. Okay, guys, we have all sorts of materials that make up a structure. So how do we go about the structural analysis? How do we go about this, guys? So now I'm going to tell you guys in a moment, okay? Because structures, they are so complex. Structures are so complex, so we need to know how we go about structural analysis. Okay, guys? Now, guys, the answer is to use analytical models. Okay, we need to use analytical models. Now, guys, we don't just take a structure, break the structure down and analyze every single materials in the structure. No, we don't do that. What we do is we take this structure, or we make an assumption of how this structure is going to react when we apply environmental load on this structure. So we make an assumption, and after making this assumption, we make an analytical model that represents this structure. Okay, guys? So we make an analytical model that represents this structure. Then we try to take a look at the behavior of this analytical model. So we try to predict the behavior of the structure using this analytical model. Okay, so doing this, we'll be able to at least get close as possible of how the structure is going to behave. Okay, guys, so we make an assumption using analytical model. Okay, guys, so analytical model as simplified representation of structure, the goal being to represent the behavior as close as possible. Okay, guys, so this simplification allows us to perform an analysis. Now, guys, there's a saying, if you can't rough it out on an envelope, you shouldn't design it. So this was from B. Lemasio. I don't know if I pronounced that right, but anyway, we are going to continue. So, guys, this is the saying, if you can't rough it out on an envelope, then there is no point there is no point to design it. Okay, that is to say, if you can represent a structure using an analytical model, then there is no point designing a structure. Okay, guys? So we civil engineers, we always represent structure using analytical model. Okay, guys? So let's move to the next slide. Now, guys, for example, consider the following bridge. So as you can see, guys, we're having a three-dimensional welded panel truss structure. So as you can see, this is a welded panel truss structure. Okay, so one way to find this out is to perform a physical load test. Okay, guys, so we are going to perform a physical load test. That is, we are going to measure the response of the structure and compare that with the analysis. Okay, guys, so we are going to take this analytical model, we are going to perform a physical load test. That is, we are going to try to measure the response of this structure. Okay, we are going to try to determine how this structure behave. Okay, how this structure behave due to the effect of the load that is being applied to the structure. Okay, so we are going to compare that with the analysis. Okay, guys. Now, when we analyze the structure, we create an analytical model. Okay, guys, like I said earlier, we are going to create an analytical model to analyze the structure. Now, guys, we use 2D instead of 3D. Okay, guys, because we need to try to predict how this structure respond or how this structure behave when it is being applied, when we apply environmental load on the structure. So we're going to create a 2D analytical model, not a 3D. As you can see, guys, if you take a look at this picture here, as you can see, this is a 2D picture of a bridge, right? So this is a 2D picture of a bridge. So we are always going to take this structure, or we are going to take these buildings, we are going to represent this using an analytical model, and we're going to use a 2D model. Okay, guys? So this is frictionless joint. As you can see, guys, these joints are frictionless, and the load are applied at the joints. Okay, guys, so we assume that all the load are applied on the joints. Okay, guys, so meaning the load is going to be applied on every joint. Okay, guys, now the members carry only axial forces. Now, guys, there is no bending, there is no shearing, there is no twisting. Okay, so these members are going to carry just axial forces. Okay, guys, now when we make this assumption, we begin to deviate from the actual behavior of the structure. Now, guys, whenever we make assumptions on how a structure is going to behave, we begin to deviate from the actual behavior of the structures. That is to say, our predictions are not accurate. Our predictions, sometimes, they can become too inaccurate. Okay, guys, when we use this analytical model. So we always need to be careful. And whenever we find out that our assumptions are wrong, we need to analyze these structures. We need to go back and analyze these structures again. Okay, so we need to always check our assumptions if it is correct or not. Okay, guys, so this is how we go about structural analysis. So as you can see, guys, this is a representative comparison of experimental and analytical results. As shown, structural analysis work quite well in predicting response. So, guys, this is the representative comparison of experimental and analytical results. So let's move on. So therefore, these methods are quite accurate in predicting structural behavior. While not perfect, they are more than adequate for the end goal. Okay? So why they are not perfect, they are more than adequate for the end goal, because we always need to try to make an assumption in order for us to design our buildings. And whenever we find out the assumptions we made is wrong, we always need to go back to correct our assumptions. Okay, so this is going to be adequate for the end goal. Okay, guys. Now, guys, there is also a saying from Norris and Weber that says the function of a structural designer is to design, not to analyze. Okay, guys? So our job to design, not to analyze. Okay, now, guys, we are going to classify structures. So we're going to take a look at classifications of structures. Now, guys, one of the first steps in assessing structures is to determine what type of structure we are dealing with. Okay, we need to determine the type of structures we are dealing with. Now, let's look at some common elements and structures type that we use today. Now, guys, we have structural elements, type of structures, and boundary condition. So let's take a look at structural elements. Now, guys, the first structural element we are going to take a look at is tension elements. Now, guys, what are tension elements? Tension elements, these are elements placed in a structure in order to resist tension. Okay, so these elements, they are placed in a structure in order to resist tension only. Okay, and these elements are very, very efficient. Now, if you take a look at this picture, you're going to find out that this is an example of tension element. That is cable, braces, and truss tension cord. Okay, guys, because this structure or these elements, they are only placed in a structure in order to resist tension only. Because these elements, they are always experiencing tension. Okay, and how can we counteract those tension? We need to place an element that resists tension only. Okay, so if you take a look at this bridge, as you can see, guys, this is Golden State Bridge. This is Golden State Bridge. Now, this bridge has a lot of cables. As you can see, guys, these are the cables. So, why did structural designers place this cable on the Golden State Bridge? The reason they place this cable is because they want to be able to counteract the tension forces. Okay, and because we know cables, they are placed on a structure in order for them to resist those tension forces. Okay, guys, so the reason the structural designers place this cable on the Golden State Bridge is because they want to be able, or they want the structure to resist those tension forces. Okay, guys, so this is what we know as tension elements. So you need to know that tension elements are placed in the structure in order to resist tension only. Okay, so let's take a look at the second structural element. This is compression element. Now, guys, this is the opposite of tension elements. Compression elements are elements placed in a structure in order to resist compression only. Okay, so their job is to resist compression forces. Okay, now if you take a look at this picture, we are having a column. As you can see, guys, we are having a column, and we are also having arches, right? So, guys, these elements are placed in a structure to resist compression. Because, guys, it is very, very easy. For example, let's say we take a ruler. If we try to yank on this ruler, it is very, very difficult for you to yank on the ruler, right? It's very, very difficult. Or let's say we have a plastic ruler. It is very, very difficult for you to yank on the ruler. But if you try to compress this ruler, it is very, very easy. This ruler is going to be subjected to compression, meaning the ruler is going to try to buckle. Okay, so the ruler is going to try to buckle. So we try to place an element that will resist those compression forces. Okay, guys, so we try to place an element that will resist those compression forces. So an example are columns, arches, and truss compression cord. Okay, so these are elements that are placed on structure in order to resist compression forces. Okay, guys, so let's take a look at the next structural element. So the next structural element is what we know as flexural element. Now, guys, these elements are placed on a structure to resist just bending. Okay, guys, so these are placed on a structure to resist just bending. Now, guys, the most common type of flexural element you will find is beam. Okay, because beam, they are always subjected to bending. And how can we resist those bending? We need to place an element that will counteract those bending. Okay, so beam is an example of flexural element. Now guys, we also have bridge girders or floor system. Now guys, if you take a look at this picture, you're going to find out that this is an example of a floor system, and this is an example of bridge girders. Okay guys, now guys, what do we mean by bridge girders? Bridge girders is a bridge that uses girders as its means of supporting its deck. As you can see guys, this is the deck of the bridge, right? And how can we support this deck? We need to place a bridge girders in order to support the deck. Okay, so the bridge girders, they are placed under the deck of the bridge. Okay guys, so these are the bridge girders. Now guys, these bridge girders, these are flexural elements because these elements, they are subjected to bendings. Okay guys, they are subjected to bendings, so we need to place an element that will resist these bendings. Okay guys, so you need to know that the most common flexural element is what we know as beam. Okay, so let's move to the next structural element. So the next structural element is what we know as shear element. Now guys, these elements are placed in a structure in order to resist shear. Okay, so their work is just to resist shear. Now guys, the most common shear element is what we know as shear wall. Now guys, if you take a look at this picture, you're going to find out that this is an example of shear wall. Now guys, what is the job of a shear wall? The job of a shear wall is to resist lateral load. Okay guys, it is to resist lateral load. And we know the most common lateral load, or the most common environmental load that buildings experience, is what we know as earthquake load. Okay guys, so in order for this building to withstand an earthquake, we need to place shear wall in the building. Okay, and this shear wall, they will try to counteract the earthquake load. Okay guys, and we know that whenever an earthquake hits a building, the building is going to try to vibrate, right? The building is going to try to oscillate. Okay guys, and how can we stop this building from vibrating too much? We need to place an element called shear wall. Okay guys, so this shear wall is what we use to resist lateral load. Okay guys, so this is an example of shear elements. Now let's take a look at type of structures. Now guys, what are the type of structures? Now guys, the first type of structure we have is trusses. Okay guys, so these are straight members connected by hinge joints. As you can see guys, if you take a look at this picture, this is an example of a truss. Okay, so these are trusses. So these are straight members connected by hinge connection. Now guys, one of the advantage of using trusses in our building is they are very, very efficient. Okay, they are very, very efficient, and they are lightweight. Okay, they are very, very efficient and they are lightweight, and they also have high stiffness. They are very, very stiff. So this is one of the advantages of using trusses in our buildings. But one of the disadvantages of using truss, guys, they are so expensive. It is very, very expensive to use truss in our buildings, because if you take a look at trusses, you're going to find out that these elements, they contain too many connections. They have so many connections. It is very, very difficult for us to fabricate these elements. Okay guys, so it is going to be time consuming. It's going to be time consuming, and it is going to cost us a lot of money. Okay, because take a look at this truss system. You're going to find out that this truss system contains a lot of bolts, it contains a lot of rejects, it contains a lot of steel. And guys, we all know that steel is very, very expensive. Steel is very, very expensive compared to concrete. So it is going to be very, very expensive, but it is going to give us high stiffness. Okay, so these are the advantages and disadvantages of using trusses in a structure. So let's take a look at the next type of structure, which is beam. Now guys, beam by themselves can be considered as a structure, okay, because they resist load through developing bending moments and shear. As you can see guys, this is a bridge that has its span, or that has the deck using a beam. As you can see guys, this is the beam. Okay, so this beam is going to be very, very economical. Okay, so we are going to spend less money whenever we use beam. Okay guys, because beam, they take less time to fabricate, or they take less time to construct. But when we use trusses, it takes us a lot of time, it consumes time. Okay, so we tend to go with beam because beam is very, 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 very easy to fabricate. Okay, so it's very, very easy for us to use a beam bridge instead of us using a truss. Okay guys, so this is what we know as beam. So let's take a look at the next type of structure. Now guys, this is what we know as frame. Now guys, frame, this is just a beam and a column connected to each other. Okay guys, so this is just a beam and a column connected to each other. So this is what we know as frame. If you take a look at this picture here, you're going to find out that this is an example of frame. Okay, this is also an example of a frame. So this is just a beam and a column. As you can see guys, this is the beam, this is the column, so they are connected to each other. Okay guys, now guys, a frame, they transfer moment. Okay, so frame transfer moment, while trusses are designed to see just tension and compression. Okay guys, as you can see guys, this frame is going to be experiencing some moments. Okay, so we design a frame to transfer moments, while we design a truss to see just tension and compression. Because if you take a look at frame, as you can see guys, this is just a box, right? So this look like a rectangle. Okay, this look like a rectangle, meaning they are going to be experiencing some bending moments. But if you take a look at trusses, you're going to find out that trusses, they have so many geometric nonlinearity. That is, the shape of a truss is so complex. Now guys, let me show you the shape of the truss. So let's move upward. Let's move upward. Okay guys, as you can see, this is a truss. As you can see guys, the shape of the truss is so complex. We have so many triangular shape. Okay, so they are so complex, meaning they are going to see just tension and compression, while a frame is going to see bending moment. Okay, so a frame is going to transfer moment. Okay guys, so let's move downward. Okay, now we are going to talk about boundary conditions. So guys, this is going to be the last topic we are going to discuss in this lesson. So what are boundary conditions, guys? Boundary conditions, guys, they represent support reaction. Now guys, when we talk about boundary condition, we are basically talking about support reaction. Because guys, we need support. That is, we need support that we attach the structure to the ground. Okay, so support attach the structure to the ground and are the main components that keep the structure in equilibrium. Okay guys, because this structure needs to be in equilibrium, because we don't want our structure to run away from us. And how can we do that? We need to have support reaction on the structure. Okay, so this support reaction, they attach the structure to the ground. Now guys, there are various types of support reaction. We have pitch support, roller support, and fish support. Okay guys, as you can see, if you take a look at this picture, you're going to find out that this structure is supported to the ground using support reaction, right? So using support reaction, this structure is supported, or this structure is placed on the ground using support reaction. Okay, guys? So boundary conditions, these are support reaction. Okay, guys? So this support reaction, they attach the structure to the ground and are the main components that keep the structure in equilibrium. So we have pin support, roller support, and fist support. Now, guys, this is where we are going to call it. So in the next lesson, we are going to continue from boundary conditions. So we're going to see how we analyze support reaction. That is fist support, pin support, and roller support. Okay, so in the next lesson, we are going to discuss more on boundary conditions. Okay, guys, so this is what we know as structural analysis. So you need to know that, guys, structural analysis is a way civil engineers analyze buildings so that they can be able to design buildings. Okay, so we try to take a look at the responses of a structure due to the environmental load placed on the structure, or due to the environmental load the structure is experiencing. Okay, so using structural analysis, we are going to design our buildings. Okay, guys, so structural analysis, this is basically a way which structural engineers analyze buildings. Okay, so we are going to try to determine the resultant stresses. We're going to try to determine the rotation. We're going to try to determine the bending moment. That a lot of stuff, guys, a lot of stuff. So this is what we know as structural analysis. Okay, guys, now this is what we're going to call it. In the next lesson, we are going to discuss more of boundary conditions. Then we're going to see how we can take a structure and we are going to try to determine the forces that are applied to the structure. Okay, so we're going to try to determine the bending moment, the shear force, like a lot of stuff, guys, a lot of stuff. So this is what we're going to call it. So if you watch this video up to the end, make sure you comment on the comment section below. If you like this video, subscribe to my channel and make sure you share this video with all your civil engineering friends, because this video is going to be very, very helpful to them. And I will try my best to make the next lesson as quickly as possible. Now, guys, this is what I'm going to call it. So see you in the next lesson. Bye, everyone.